Okay, so we're going to take a look at marginal analysis. So marginal analysis is used in business and economics, and we generally use it to approximate, like for instance, the cost of producing the next item. So if we're applying it to a cost function, it would be what is the cost of producing one more item? If it was revenue, what would the revenue be for one more item? What would the profit be for marginal profit? What would the profit be for producing one more item, right? Now, what you want to realize is that these are quick approximations. They quickly get you roughly in the neighborhood of your answer. So these problems are going to involve both calculating the exact answer and then the marginal, say, cost. And then you'll see that the values come up real close, but not always exactly the same. So we got to be careful about that. And the idea basically comes down to this. So what do we have here? We have our function, right? We have the red function here. We have our tangent line, which is representing the derivative. And then we have this vertical line. Well, our tangent line is based at the point for x equals 2. So if I'm right here, you can see those line up perfectly. Now, the further I start to get away from that point, my tangent line is approximating our curve less and less. And then you can see over here, it's terrible, right? But as I'm in close, it's still doing a decent job of, like right here, it's still doing a decent job approximating that function, but it's starting to get a little bit of a separation. And that's where the approximation comes into play. The difference between the actual function value and the one approximated by our derivative is going to be off by a little bit. So, and it's the same in the other direction. If we move over 1 unit in the other direction, the closer you are to the point where your tangent line was calculated, the more accurate you're going to be. The further you move away from that, you start to get this error involved. Okay, so keep those pictures in mind as we go over this. Okay, so here's the idea. If our function, our cost function, is the total cost to produce x units, so capital C of x is the total cost to produce x units, then it makes sense that the exact cost of producing the x plus first item is c of x plus 1 minus c of x. So this is the cost of producing x plus 1 items. This is the cost of producing x items. If we subtract them, it tells us the cost of that last item. Now, this is important because for most companies, your costs and your revenue and all that kind of stuff changes depending on the number of units you produce. Like a lot of stores are like this, right? If you go to one of these big box stores, you get a really good deal on something, but you have to buy a larger amount of it. Well, that's because companies can reduce their cost if they produce more. So they're getting you to buy a bunch of it, the cost goes down. Okay, so that's why you can't just calculate the cost of the first item, because usually the first item you produce, really expensive. The millionth item, probably cheaper than that first item. So we want to know what's the cost of producing one more item. And that's the idea behind this marginal analysis, is that we can approximate the cost of producing one more item. So we see that down here. If we go, we want to approximate the cost of producing the x plus first item. We just take the derivative and evaluate it at the value we care about. So that's a pretty quick calculation. And sometimes you might only have the marginal cost function. You might not even have the exact cost. There's different reasons why you'd play around with this. But that's the idea. We can use the derivative to approximate the exact value. So let's look at a specific example here. All right, so let's take a look at an actual example. So we've got c of x is equal to 10,000 plus 90x minus 0.05x squared. So that's our total cost function. Okay, that's the cost for producing x units. All right, so if we want to find the exact cost, we would just stick 501 in here, stick that into this function, then stick 500 into here, subtract those two values, and you're going to get 39.95. Okay, so that's the exact cost of producing the 501st item. All right, but so let's just say we want to approximate that using the derivative. So what we would do is we would calculate the derivative, c prime of x, and that should be pretty easy to do because it's a polynomial, and taking the derivative of a polynomial is really easy to do. So we see it right here, right? When we take the derivative of the constant term, it becomes 0. When I take the derivative of 90x, it becomes 90. And when I take the derivative back here, we bring the 2 down. 0.05 times 2 becomes 0.1. and then we decrease the exponent by 1, giving us an x. So this is our derivative right here. And if we want to evaluate that at 500, you would just stick 500 into this derivative function, and we get 40. So you can see that this approximation is really close to the actual exact value. So it depends on the problem you're working on. Do you want the exact value, or do you want an approximation for it? And in this case, it worked out pretty good, right? $40 is probably close enough to this to help you make your decision on whether that next item should be produced or not. And you can see that they're very close together. And in fact, there was less calculations going on to calculate this marginal cost. So if all you want is an approximation, then this is going to be good enough for you. If you need it to be really, really exact, then you go in and you calculate it exactly by hand. Just depends on the problem that you're doing. Okay, so make sure you read some of the examples in the book. You want to make sure you understand the language that they're using and how they're saying it. There's going to be numerous times throughout this course where you want to take a look in the book and pay attention to the way they're writing their conclusions to the problem, the way they're saying things. So like, for instance, in the book, they say, at a production level of 500 tanks per week, the total production costs are increasing at a rate of $40 per tank. We expect the 501st tank to cost about $40. That's the interpretation of what we just did down here. Right? Because you can't just do these calculations and not know what they mean. You have to be able to communicate them and make sense of them so that you can do something with them. So make sure you read a couple examples in the book. Read how they make those statements so that you can make the correct statements when you do this work.